All right, section 5.2. We have a triangle. We got a couple more words to learn. First word is called median. Median. You might have remembered that from Algebra 1, even before that, mean, median, mode. So median, basically, it's the one in the middle. That's right, okay? So think of in the middle. If you go down the road, you see that grassy area in between the lanes, okay? That's called the median because it's in the middle, all right? So what we're going to do is this. Here's what a median of a triangle is. The median of a triangle starts at a vertex, and where do you think it hits? In the middle, or the what? The midpoint. Let's say midpoint, not say middle, because we don't say middle very often in geometry. We'll say the midpoint. I don't know. Does that look close to the midpoint right there? Okay, right there, we'll say. All right? So that's a median. That red line right there is a median. Well, let's draw another median. Do you remember from lesson 5.1? We did a couple things, and what did we do? We did perpendicular bisector, right? And they all three met at one point, right? So we say those lines are what then? If three lines meet at one point, what do we call those lines? Concurrent. Very good. Concurrent. All right, if you're taking notes, you should just flip, right, probably one page and you'll see that word. We're going to get the same thing when we do the medians. So watch this. If I take this and hit the midpoint of the opposite side, again, I'm starting at a vertex and hit the midpoint of the opposite side. Where do you think the midpoint is? Around here somewhere? Does that look pretty close?
Yeah.
All right, I'll believe you. All right, so that's another midpoint. So these two lines intersect each other right here. We're going to do one more. Now, if I did this accurately, and if I hit the midpoint of the other side, guess what? Those three lines will all meet at that one point right there. That means those are concurrent to each other. Now watch. Remember, we started here, so that means this side and this segment and this segment are equal to each other. Right? We started, let's see, then we came up to here, didn't we? We came down here like this, so those two sides are equal to each other. We started this vertex, we went to the midpoint of the opposite side, so that means these two sides are equal to each other. Everybody see that? That means we hit at the midpoint. We started at a vertex, and we went to the midpoint of the opposite side. If we do that, we're doing the median. Okay, that's how we find the median. Guess what? They all intersect at one point. Everybody with me? Now remember what we did before. We said there was something special about that point of intersection, or that point of concurrency. We said there was something special on those other two triangles. Okay, come on, pay attention, please. No, you're not. Not doing that, you're not. Well, you're just, Kenny, you're disturbing other people then. Okay, shh. Because all she's doing is looking at what you just did right there, okay? And she even commented on it. All right, so just pay attention, please. Watch what happens here. This point, it's not equidistant from the vertices. It's not equidistant from the three sides like we had in the other situation in 5.1. But there is something that is special about this point. This is kind of interesting. From the vertex, listen very carefully, from the vertex to the point of concurrency is twice as big as from that point of concurrency to the midpoint of the opposite side. I said a lot of words, but pay attention. Let's not drift off. Let's look up here, concentrate, focus. From the vertex to this point is twice as big as it is from this point to this midpoint. Everybody see that? So what if this was 10? What's this going to be from right here to right here? It's going to be 5. That's right. Here's another way. It's from the vertex to the... Oh, by the way, I got to give this a name. Almost forgot. That point right there, remember we gave it a name on the other two? We found the circumcenter. We did the incenter, right? This has a special name too. It's a little bit different. We call it the centroid. Yeah, it's kind of a neat name. It's called the centroid. Okay, that's all it is. It's just find the median. It's the point of concurrency of the medians of a triangle. That's the centroid. So if I draw a median to all three sides, right, from the vertex to the midpoint here, vertex to midpoint, vertex to midpoint, they all intersect in one point. That point's called the centroid. All right. Now, what's true about the centroid? The centroid is a special point because from the vertex to the centroid, is twice as big as it is from the centroid to the midpoint. Everybody hear that? So if this was 10, this would be 5. Of course, if I told you that this was 5, now I know you already know what this is. What if this was 5? What would this be from here to here? That would be 10. What would the whole thing be? It would be 15, right? So the whole median would be 15. Or we could say this. If you look in the book, it says this. It says I think it says the centroid is 2/3 of the distance from the vertex to the midpoint. It's 2/3 of the way from here to here. And think about it. Is it 2/3? Well, from here to here is 10 out of what? The whole thing. What's the whole thing? 15. So simplify that. What goes into 10? 5 does, right? 5 goes into a what? Twice. 5 goes into that. Yeah, it is 2/3, isn't it? So from here to here is 2/3 of the whole thing. Or it's twice as big as this part right here. So which one's the longer section? From where? From the vertex to the centroid. From the vertex to the centroid is twice as big as it is from the centroid to the midpoint. You hear me? We had a problem on the honors class on their test, and the picture wasn't exactly drawn to scale, and they couldn't tell which one was the bigger one. And a lot of people even asked on the test, well, which segment is the bigger segment? Like, I can't tell you because we talked about it when we first did this lesson. So I'm telling you right now, it's from what? It's from the vertex to the centroid. That's the longer one. In fact, it's not just a little bit longer. It's what? It's double. It's twice as big as from here to here. This is the midpoint. That's the midpoint of this side. Okay? That's the midpoint of this side. See how these two segments are equal to each other? That means this has to be the midpoint. Agreed? So, from the vertex to the centroid is twice as big as it is from the centroid to that midpoint. Make sense? All right. And they could do a lot of different things here. They could, I don't know if I have a good example here. Let me just... let's do this. What if I call this A, call this E, call this P? What if I said that AE was, let me see what I want to make it. Let's say AE was, I don't know, I'm just making this up. Let's say 15. All right. So I want you to find what AP is equal to, and I want you to find what EP is equal to. All right. Okay. How did you? Well, you know what? Why did I pick 15? Let's pick something. Let's pick something different than that. Let's go, because right, I already got the 5 and the 10 there. Sorry. Let's go 27. Let's go 27. All right. So AE, that means this whole entire thing is 27. Now remember what we said about the whole thing? The whole thing is 2/3 of the longer section. So that means the shorter section, if this is, watch, if AP is 2/3 of the whole thing, what fraction is the shorter one? Say it, Dion. You said it. I thought you just said it. If this is 2/3, what's this? Forget the numbers. Forget the numbers right now. If this is 2/3 of the whole thing, this is what fraction? It's 1/3, right? You get it? 2/3 and 1/3. So you know what might be easier? What might be easier is to find the shorter section. If I know the whole thing, how do you think you find the shorter section? Well, I just answer my question. I'm not looking for the answer right now. I just want to know how to find the shorter section. Divided by 3. That's right. Take the whole thing, which is AE, which is 27. How do I find the shorter section? It's 1/3 of this. Or just divide it by 3, right? Multiplying by 1/3 is the same as dividing by 3. So what's 27 divided by 3? 9. It's 9. So that thing right there, let's get rid of the fractions. Okay, so that little bit is 9. You see that? So if I know the whole thing, how do I find the shorter one? I just divide it by 3. I got the shorter section. Now, how do I find the longer one?
You double it.
That's right. You just double it. That's right. It's double the shorter one, right? Because 2/3 is double 1/3, isn't it? So I just double it, and I get 18. Now I realize you guys already came up with the answers, but I want you to answer my questions as I ask them, okay? So if I give you a number, how do you find the shorter side? You take a third of it, okay? How do you find the longer side? You just take the shorter one and you double it, okay? Make sense? Okay, what if, we'll call this B, we'll call this F, okay? What if I told you BF was 36, okay? And I asked to find BP and FP. Give you 10 seconds to figure it out. Go. You got it? All right, Vaughn, what do you do? The whole thing, BF, is 36. So what are you going to do first? Vaughn? Divide by what? By 3. I would divide by 3. And which one would be 12? The shorter one, right. Remember, the short one is a third of the whole thing. So 36 divided by 3 is what? Is 12. And then double it, and it's 24. Or you could have just gone 2/3 of 36. But I think it's easier. Okay, I think it's easier to do 1/3, because all you got to do is divide by 3. Okay, and then once you get this, then you double it and you get this. I think that's the easiest way to do it. You could do what you did, Rayvon. You could have gone 2/3 of the whole thing, got 24, then take half of that, and that would be 12. And that would be fine. All right, there wouldn't be anything wrong with that. I just think it's a little easier for me personally to divide by 3 and then double it, and you get this right here. Everybody with me? Now look, if I gave you the short side or the long side, the rest is pretty easy, isn't it? So let's pick another number. Let's say I said that was 3. Then what would PC be? PC would be 6, and what's the whole thing? GC. It's 9. So if I give you one of the segments, the rest is really easy, isn't it? The hardest part is if I give you the whole thing, all right? And it's not really that hard, is it? Find the whole thing, divided by 3, you get this, double it, and you get this. You okay with that? All right, that's not so hard, is it? Now, you know they're not always just going to give you numbers. Sometimes they might make it like x plus 3 or something like that, all right? But I think for this particular problem, I think they mostly just give you regular numbers to figure out. All right, so there you go. Everybody okay with that? All right.